Let's move on to our first speaker. Attila is an automotive professional with 15 plus years of work experience and 10 plus years leadership experience. Most of his time spent in Hungary, a couple of years in the US, which has fundamentally formed his viewpoint regarding cultural openness and understanding each other. In his current role as Director of Software Engineering at the Cross Computing Division at Bosch, he enjoys having a real positive effect on automotive via leading a state-of-the-art software-focused team and representing the company's motto, invented for life. This practically means the ownership of functions like automatic emergency braking in the car, which helps them to prevent accidents and save lives. Software mindset revolution in an automotive company. Please welcome on the stage with a round of applause, Attila Mészáros.
Hi everyone, happy to see you. And even if this is the smaller stage, I will try to make it the loud one, or to make it the interesting one. The topic I brought to you today is about software revolution. I would say it's very important to see that automotive and tech or IT is not two different things. I would like to give you some insights why we think that this is the fact at Bosch. Just some words about myself. So I've spent 15 years at the automotive, different areas. Some of them were leadership related, and many of them were technology related. And I would like to guide you through this discussion today. If you see on this picture, you can see a lot of things. I call it future of mobility. I would call it the future of a city center. You can see a lot of things. Not that many vehicles, as you might see in today's downtown, and let it be in Budapest or anywhere else. But you can see a lot of mobility-related stuff: two-wheelers, parking situations, car sharing, cool cars which might look like electromobility cars. And this picture contains, in a condensed form, a lot of things I would like to talk about today, and to highlight that how software is important in the automotive. So behind this big picture with a lot of different scenarios, there are four things, and that's personalized mobility, that's automated mobility, that's connected mobility, and that's electrified mobility. And let me guide you guys through these four one by one, and then explain how that relates to software. So first off, let me start with the personalized one. What is personalized in today's life? For instance, your phone. If you check out your phone, that's yours. That contains a lot of things. Wherever you click, you know what to do, because this belongs to you. You can imagine that many, and I would say in a growing amount of things in your car, are getting personalized. How it works today: you buy a car and you configure it to yourself, and that's how it is. It's then kind of constant. Modern cars have entertainment systems. There you can download apps, and there you can reach some certain level of personalization. But this is today. In the future, way more things will be personalized in your car. I will talk about that in the next couple of minutes in a more detailed way. Another big megatrend in the automotive, which I would say drive a lot and needs a lot of investment, and majority of us as well here in Budapest are working on, is automated mobility. I don't want to talk about all the details and go into the levels of automation. But from today's cars, where you have assisted driving, which helps you to avoid certain scenarios in driving, up to the full automated driving on each and every situation, in every situation, you can see these levels. And this automation requires a lot of changes in compared to today's cars. The next big trend or driver is connectivity. I would say in today's cars, today's modern cars as well, almost nothing works if this is not connected. And you can not just imagine what you see, your phone and your Spotify and whatever apps you are downloading it to your car, but you can imagine as well things that, for instance, the traffic-related data. And traffic-related data is not just helping you to find the optimal route to your next station, but as well helps your car to avoid collisions. If your vehicle knows that in the next corner there is an accident because your vehicle communicates to the other vehicles, or your vehicle communicates to the infrastructure, that can help us to save lives. And this is one of the big motivations in the current trends of the automotive industry. And the fourth big trend is, I would say, the obvious one, which everyone is hearing in the media, and if you get in the streets, then you can see it as well. It's electrified mobility. Instead of fuel-powered cars, we are heading towards electromobility, which is as well a different type of development, a different type of architecture. I would say from the mechanical point of view, it's a little bit more simple, but on the software side, it's quite complex. I don't want to talk about these four in details today, but I want to talk about what is behind that. That's what we call a software-defined vehicle, a different type of an architecture of the car. In this part, I've prepared something interactive, which we cannot make in this session, but I would like to ask you some questions. And even if you can't answer me, please think about it. Just to highlight you the complexity of the automotive from the software point of view. Just if you can imagine how many lines of codes have an average iPhone app. That's about 40K. Let's imagine the same question for the Firefox's latest version. This is a couple of millions, almost 10 million. Can you imagine it for Facebook? Backend, so not just the app on your phone, but everything. This is a couple of tens of millions. That's about 60 million lines of code. But if you check it, currently up and running high-end car, so not the future, this is today, this is about 100 million. Just to show how complex it is. But for sure, this 100 million, this is currently not on a single vehicle computer. This is distributed among the car in several smart sensors, in several ECUs. I would say the architecture of the car, the architecture of the ECUs and sensors, that defines the car. And even this complexity will increase in the future. We are heading towards 300 million in the next couple of years, and in the case of the fully automated vehicles, there's a level 5 of automation. We can talk about the 1 billion lines of code. And that cannot be managed with this architecture, which you can see with the distributed ECUs and distributed smart sensors. For that, we need something new, and that's what I call a software-defined vehicle. Once again, what drives this software-defined vehicle? One thing is the complexity, which I was mentioning. The other thing is that more and more things in your car are getting, I would say, from the functionality point of view, complex. Let's just imagine your car. It has several sensors around it. Like you can imagine a radar belt. In each and every direction, a radar is looking around. Same for cameras, like in parking situation, your backwards seeing camera, but in many cars as well, you have the other cameras looking around the car. This is quite complex on one side from the hardware point of view, number of sensors, but on the other side, these different sensors gather different data. They fuse this data. They use this for different functions, life-saving functions like emergency braking, adaptive cruise control to hold the distance, and tons of different functions. So the function development is getting complex. That's why, for instance, the more than 50% of the R&D personnel at Bosch worldwide is working on software. 44,000 people. A couple of thousand of them here in Budapest, the rest around the globe. But 44,000 working on software because of the functional complexity. The other thing is, which I was mentioning with the analogy of the phone, and I will have another analogy to the phone, is the consumer expectations. You have your phone. I'm sure each of you guys have it around you now. This is fast. This is shiny. This is connected. This has everything you have with one click. You expect, and I would say the future and more younger generations we ask, they expect the same from the car. It can't be less shiny, can't be less connected, can't be less smart than your phone. And the third topic, I would say, this is less visible for the consumers, but rather visible for the ones who make the cars, is that there is really a shift in the value chain. In the hardware, in the mechanics of the car, we are going towards standardization. A lot of components are off the shelf in the future, but the software, that's the real differentiating factor. That's why the automotive invests into software more and more. And maybe one more thing to mention regarding to this. Today, if you buy a car, then it's how it is. You get it, you buy it, you have been buying several extras, and this is running. If you have a software issue, then you go to the service station and you get an update. If you are lucky and you have a car which is capable of doing it over the air, then it does it over the air for certain functions. In current vehicles, it's not done for safety features, but it's done for a lot of entertainment features. In the future, this is completely different, and we are working towards that the life cycle of the hardware in the car is as it is, as you buy it, but the rest, the software, is evolving in the future. As well, you can see here a kind of an analogy to your phone, where it is like a piece of hardware capable of a lot of things, but you can upgrade it with several extras, like with your applications. Let's stick to this analogy to the consumer electronics, to the phones. And one more question, which we can't make it interactive. But what do you have if you buy your phone? Your phone is capable of a lot of things, but this is empty. And what happens a couple of hours later? The phone is yours. You sign in, you download your things from the cloud, and you will have in a couple of hours really everything which is yours. And can you imagine this thing to your car? And I'm not talking about the entertainment system that you download your Spotify and everything, which you can do with today's car. But I mention it, or I state it for the functions of the car. Even smaller things like seat heating. Car is capable to do it, but it's not available in your car until you buy it or to subscribe it for a couple of months, like in winter. Or you can imagine this thing even for automated driving. This is something which the automotive suppliers and parties in the world are talking about, to make the vehicle capable of a lot of things, but to really connect it to the user. Completely the same topic, but from different angle. What happens if you subscribe to Netflix? You will have a Netflix at each of your devices, independently from your platform, independently if it is a smart TV, it's a phone, it's your console or whatever. You have it because you subscribe. Can you imagine this as well for your car in the future, for vehicle functions? Let's take the example. You have a subscription for automated driving. You have it for your own vehicle, but if you go to Germany to a business trip, or to Bali for a family trip, and you rent a car, or you do car sharing, then with the same subscription, you have the same functions in a different car. This is rather a vision. This is not something which you will see in a couple of years, but I'm quite convinced you will see in around 10 years. So just to imagine this as the future for autonomous driving, for this, and that's why we are talking about this thing a lot at Bosch. Companies like Bosch, but as well same for the OEMs, for the car makers. These parties need to be good in two things. Need to be good in hardware, to be able to make the parts of the car, or the parts of the phone, parts of the car. We need to be good in software to be able to make these these applications, these functions the best. You're using Netflix, but you might not use Hulu because you prefer Netflix. Netflix has more content. It has a better user experience. There is a way, there is a reason, software-related reason, why you prefer that one. That's the differentiating factor. But and that's my view. To make us to be the best, we need to be good in both. And therefore, me the analogy, and I'm not saying the iPhone is the best and Apple is the best, but let me use this analogy. The M chip which Apple is using, that's a perfect thing. They are doing it for themselves. They are able to integrate on that platform their applications way more efficient than anyone who is making the Lego pieces from different sources. And from my point of view, this is going to be the holy grail of the automotive industry in around 5 to 10 years. This is nice, subscription in the car and car functions like Netflix, but car is in one point very different to the phones. You can't hurt really anyone with your phone. I mean, you can if you really want to, but it's not that easy. But with your car, it's way more easy. So there is a clear difference here. And currently as well, the biggest portion of functional safety, so saving lives, avoiding incidents in the car, or in the streets, that's software intensive today as well. We are doing a lot of investment to be able to make fail-safe and really safe functions on the software side. But this is really increasing with the vision I was mentioning. So how that relates to this Netflix analogy, it doesn't. So safety functions in the car shall not be over with your subscription. Automatic emergency braking and functions like that must be available per default as you buy your car, independently from connectivity, automation, subscription, whatever. Functional safety in the vehicle is not a game. One more thing, which I would say, if you make a presentation today, you cannot avoid it. So you cannot not talk about GPT. And there is a big question mark in every industry, including the automotive. Okay, how that relates? Is this changing everything? Does it change anything? And I would say this potential is uncovered, especially if you're not just talk about generative AI, but generic AI. But there are some areas where we can see already the potential, and this has been started to be used. One thing is vehicle diagnostic. Hey, my car, what's your problem? And then my car tells you its problem. So if it is equipped with generative AI, then diagnostics in the future will be way more easier, and not just talking in failure codes which are read out via cable or something. Generally speaking, the user experience in the car, once the car is communicating with you on eye level, then you understand with your car each other way better. So I would say, generally speaking, the user experience will be boosted up with generative AI. And the third thing is that that relates to the development itself. And I'm not talking just about the fancy word prompt engineering, but if we can use any GPT function in the development of the vehicle, then I'm quite sure that we can boost up the development and make it more efficient in the future. But for that, we need to ensure that the data which we are using is not unverified. So for the development of safety features, for instance, in the car, you can't use unverified internet data. You need to have a closed loop where you ensure that the data which is recorded or simulated or whatever, that's used in a safe and closed circle via the GPT functions. That's a very big thing for the automotive industry, not just say, hey, ChatGPT, make my car or build a car, and with a lot of prompt engineering it's done. No, it cannot happen. The usage of data, and I will talk about that a couple of minutes later, or ensuring that the data is verified, is super important in that regard. So my message regarding ChatGPT, even if this is not a very detailed statement, but my statement is that generative AI will not change these trends, these directions, it will accelerate. It will enable and accelerate. It will help us a lot to bring these, I don't know, 12 years of vision to 8 years. Don't know the numbers, please. I'm just guessing, but I'm quite sure that this will help us to bring this thing closer to now. In the next couple of minutes, I would like to talk about bringing these visionary big things to closer, because we have here in Budapest an engineering center, which is, by the way, outside of Germany, the biggest one in the Bosch world. In the Bosch world, that's 400,000 people. 90,000 of them are in R&D, and 3,000 or 4,000 of them are working here in Budapest. So that's really like a big center. And in this center, we want to shape this. We just don't want to do what is told, but we really want to shape this future of automotive. And what we are doing, a couple of pillars regarding to this. First thing, that here in Budapest, we are shooting on as high level of responsibility as possible, not to do what is told, but to really real research, to be responsible for products, for platforms, and even for complete generations of radar systems, ECUs, whatever. The second thing is that, and I was mentioning at the ChatGPT part, the importance of data in the automotive, in the current function-focused automotive. Data is everything. If you have real live data from the vehicles in your system, and you can use it to teach an algorithm, if you can use it to simulate, to verify if your software is working correctly, that's everything. And that's why the current so the automakers are investing a lot to be able to collect these data and to verify whatever is happening on the road, whatever situation where the driver is making a decision, how that correlates to the assumption which we were doing in our software. So data is really important. I don't want to talk about agility now a lot, but just wanted to mention that I would say classic or water flow or whatever, just do requirements, understand it, and then do your development, which was quite well working in the automotive for 50 years. This is not working anymore. The classic automotive was working like, if you have a product idea, do some innovation processes, couple of years, and then realize your product, couple of more years, and then sell it for 8 to 10 years. That's the classic way of the automotive. This is not anymore the case. This is not working based on the trends I was mentioning, based on the expectations of the customers, and based on all what I was just explaining. And for that we need agility. We need to think in increments. We need to, I would say, develop as all the other parties in the IT industry, but combined with this complexity which I was just mentioning. For that, performance of software, and I'm quite sure that there are a lot of presentations around software performance here in this conference as well. This is something which we were not measuring in the automotive 5 years ago, but this is something which we are in the last couple of years started and really pushing to measure and to improve the teams, to build down the silos, to be efficient, to deliver whatever is promised to the customer as soon as possible. But there is the most important pillar, which is about the focus on the people. And there is an initiative currently running inside the company here in Budapest. This is really something made in Hungary, and I would say there we are showing good example to the other sides of Bosch, even to the headquarters in Germany, how we focus on our guys on a software level, from the software point of view. And that's where we were brainstorming a lot. Okay, what does that mean to be a software worker, to be an IT company in the automotive? How we need to shape our culture, our way of working, our tools, our IT backend, whatever you can imagine, everything which is around the people to better fit to be a software company. And there we initiated a couple of things. So this is a little bit of advertisement, just that for that you need to have an office which is fitting to this culture, which is fitting to this this mood and to this young kind of thinking with full flexi options. So you don't need to come to the office; you can work from your home every day. Another big thing where we are investing a lot to analyze and to see how it is working is what we call healthy teams. If you put 5 guys together, that might not yet even be a team. You need to invest a lot to be able to see that how this team is working with each other, what kind of mission they have together, and how that is accomplished. And for that you need all the other things like performance, software performance measurement, focus on the data and everything. But if the chemistry between these 5 guys is not working, then the team will blow up. And in my eyes, at a modern company, you need to, as a leader, you need to serve the people, and you need to be able to make this bond, whatever the cost is. At Bosch, we are investing now a lot to software career path, we call it. That means that you are not just a software worker who is getting more senior and then going upwards in the career, but we are investing into a structure where we see that in this industry we have, and I will not name them, but we have 15 different career paths for software workers. And this is not about system engineering, this is not about hardware engineering, this is not about line management, this is pure software. There we see 15 different focus areas, like you are focusing on DevOps, you are focusing on data mining, you are focusing on the AI part, you are focusing on the embedded part, base software, algorithm development, a lot of different phases. And for sure these are not career paths like metro lines, you are going from one station to the other like in a straight line, but these are interchangeable. And that's where we are supporting our colleagues to be able to jump around and build up a career from different angles. I do believe that the automotive software complexities is getting more and more complex, so this number of 15 will even increase because we have a lot to do. If you lead people, if you lead software people, you need to be able to understand the software. That's one of the mottos which we are pushing and supporting our leadership team, because we really believe in content-driven leadership. So you can't lead software people without software experience. And this is not black or white, this is something which you need to work on, but currently we are focusing and pushing a lot and investing a lot to be able to assess and as well to support our leaders to be able to lead software people. We always talk about DevOps and how that relates and how that works in this project and how efficient the pipeline is and etc. But one part, I would say the ops part, is still to be improved, and I want to be honest, that's not yet perfect in many of our projects. We need to invest more, but I would say each of our projects now have CI/CD pipelines, have I would say several steps how you merge your software back to the main path, and etc. And this has now built up, and we are working on its efficiency via measuring the software performance. I was talking a lot about our software people, but we have a lot of non-software people around in that. It can be our supportive guys like HR, quality, even higher management, but it can be as well the hardware guys, mechanic guys, whoever else. And they need to understand what we are talking about. And that's where we are investing as well a lot, to make them able to understand software, to make them able to cooperate with us, and I would say make a hardware-software interface smooth and understandable from the other side. One more thing, which is my favorite one. If you're focusing on project, and that might be not just relevant for software, but if you're focusing just on deliveries, 110%, my customer is hitting me, I'm doing my job and I'm delivering, then you will not focus on the future. We need to find a healthy balance between target orientation, delivering today, and future orientation, being able to deliver tomorrow. And future orientation can be innovation, automation, education, self-education, or educating each other. We need to find the time for this, and we need to find a framework for this. And I would say in the best project, in the coolest project, it's always working. But how about the worst project in the organization? And I'm sure this is not just an automotive thing, but this is the case everywhere, that we have good and bad projects. We have task forces, we have different situations, but in an average, we need to find the healthy balance between this target and future orientation. And that's where we are now investing a lot. We are doing one-time events like hackathons in-house, so within Bosch for Bosch guys. We are doing innovation frameworks and promoting and pushing and challenging the projects, that not to have task forces 24/7, but to have a healthy focus on the future as well. After I'm finished, one colleague of mine will join on the stage, and we'll talk about this a couple of minutes. But before he's coming, let me wrap up and show you some conclusions. So in my eyes, there are a lot of changes in the automotive industry. I would say more than ever. The biggest changes in automotive so far was to switching from horses to combustion engines and to real vehicles. What is happening now with the four trends I was mentioning is comparable to that. So really a lot is changing. If you can recall the picture with the city center, that's really dramatically different from the city center which we see currently. And most of the changes in between is related to the automotive. And in this journey, the differentiating factor is not under the hood, not really the parts of the vehicle, but it's to be searched in the software of the vehicle. I see a lot of analogies to consumer electronics, but safety is none of them. That's very important for me, and that's very important for Bosch. The safety is not an option to be a part of a subscription or something. So these changes are ahead, and we here in Budapest want to be prepared, and therefore focusing on our people. So thank you very much. That was my part, and before wrapping up, I would like to give the word to my colleague, who will mention two examples or two concrete things regarding focusing on the people and then ensuring that they are not just focusing on daily deliveries. Thank you.
Hey there, let me know if you can hear me. Good, great. So, as Attila mentioned, we wanted to give the time for our developers to really work on what grinds the gears. I'm sure that you've been in the situation, you're working on projects, deadlines are coming, there's a shitty tooling, shitty working environment, you probably want to fix it, probably you always know how to fix it, but you don't get the time for that. Exactly, that's why we decided to organize an internal hackathon. That's not yet that, beautiful colleagues. Yeah, organize an internal hackathon for our colleagues, open up the beautiful auditorium, give them 24 hours, some relaxation area, some food, and let them really work on what grinds the gears. And that's how these excellent solutions and projects came up. Of course, there were some which were focusing on our core business, the next generation parking assist features, etc. Of course, there were some topics about the evergreen AI and cloud topics, but the most interesting thing was that there were 4 teams who were targeting reducing queuing up in the canteen for lunchtime, lunch trigger. I mean, you can see really that you need to go down to the bottom line of Maslow pyramid and solve first the problems there, give them food, and then you can work on the park assist features. But not only internet hackathons were organized last year, we were also curious about what people outside from Bosch think, what is ongoing in the automotive industry in the software. So we decided last year to have a Code Like a Bosch hackathon. I also have this t-shirt, it's quite cool. We invited a couple of hundreds students and professionals from external companies. We gave them 48 hours professional mentoring from our experts, professionals, and we brought up 2 challenges, one hardware challenge. I'm not going to talk about it because it's a software conference right now, and the other one was a software challenge. And of course, we had some thousands of euros in total price, so that was also the motivation. But let me show you the example, the challenge that last year these guys needed to solve. And this is pretty much showing up very good what our everyday work is. So here you can see a basic schematic of a car. The blue one is the car. There is a front-looking camera and 4 corner radars looking all around. And the task was to create a so-called object tracking system, which means that all the sensors are looking at and seeing the objects, the cars, vehicles, pedestrians around us, but they don't see separately the whole environment. The goal was to create a model, let's say, where you can track through every vehicle coming from in front of us when leaving the environment of the car behind. That's the little purple crosses that you can see. They could use any kind of technology. And the second part of the challenge was to create this blind spot detection feature. I mean, I'm sure that you probably have seen that in the side mirrors of the cars, there's the little orange stuff that is beeping up and there's something which is in your blind spot. But in this case, also the sensors have blind spot, where the sensors don't see what is there. And this task was exactly targeting this. And this is also a big topic we are currently working on and always developing. Using less sensors, it's more efficient, costs less money, but higher functionality. So that was the other part of the challenge. And of course, we are always curious about innovation. So we were curious about the innovative ideas. And let me just show up the winner team's solution, what they could solve up in 48 hours. So basically, we provided them some measurements. The whole simulation, the whole GUI was created by themselves. And the red vehicle is the ego vehicle. The red rectangles are the blind spots. And you can see when the vehicle is coming and in the sense of blind spot, then there's a warning. I mean, the red rectangle is showing up and bleeping. Yeah. So basically, they were the winners. They got, I think, 8,000 euros. 3 guys, so that was a pretty good 48 hours hourly rate, if I would want to see. The other topic, I'd like to also show you the innovative part of their solution. This is about connected vehicles. Attila also talked about that. Here, the red car wants to turn left, but its sensors doesn't see the pedestrian that wants to cross the road. But there's the blue car coming from the right. Its sensors can see the crossing pedestrian. Therefore, the blue car communicates to the red car that, hey, probably you should not turn, but you should stop because you will hit that pedestrian. Yep. So this is their solution. This is an innovative idea which will come very soon in the future with the connected vehicles, but that's not yet there. So I hope I could give you some insights what we are really working on now. And I'd like to wrap up the presentation. Thank you very much. And before you go to lunch, if you have any questions, then feel free to ask. Thank you.
All right. Thank you very much. Thank you, gentlemen. And we have a question that came in that you can see on the screen as well. Can you share details about your SDLC and CI/CD pipeline? For example, how do software engineers validate features? What is considered pre-prod staging? What is prod?
So it's my turn, OK? Yeah, indeed. So for CI/CD, of course, this is about software integration, especially in projects which are targeting customers, so where we are really at the face for the customer. We have quite a lot of, let's say, Jenkins jobs, which are checking the code quality, which are checking whether we are making the functionality right and whether we are making the code worse or better. These are, of course, pre-production checks. But I think, as Attila mentioned, in CI/CD, in DevOps, we always have the, let's say, place to improve. So this is indeed a task where we are, wanting to getting better. However, we have a pretty good solution right now. I think there's still space to improve.
Maybe just one thing to add. So we are adding software in the loop tests at the end of our integration and in the daily builds. We are on the way as well to add hardware in the loops, to maybe not the hourly or not even the daily, but at the weekly tests. So this is a stage approach. We have a quality check and a couple of unit related checks at once you are merging back to the main, but you have a lot of daily quality checks as well, mainly focused on software in the loop, and we have a lot of things which are running over the weekend, which are really connected to hardware.
Thank you very much. Thank you, gentlemen. A round of applause, please, for our presenters. Thank you.
Thank you.
Thank you.